how can I solve quadratic? How can I solve quadratic equations using the quadratic formula? Bum, bum, bum. It's probably one of the most important things you will ever learn in math. I'm not going to get into how we came up with the quadratic formula here. You could probably find other videos on that. You'll want to look into completing the square and where this formula comes from. But here it is. Memorizing this is one of the few things you might want to memorize in math. This is how you can find the roots of any quadratic equation. You can kind of eliminate, you wouldn't need to necessarily factor it, although factoring it can be easier as this can become a bit cumbersome depending on what numbers you're dealing with. X equals negative b plus or minus b squared minus 4ac. So there's really two parts. There's the square root of b squared minus 4ac, and this term underneath is called the discriminant, D-I-S-C-R-I-M, and I'm going to pretend I know how to spell it. Discriminant is here, and then if you notice this negative b over 2a, remember that's the axis of symmetry. So I told you we'd come back to this, you'd see it again later. And the b's, a's, and c's in here represent the parts of a quadratic function in standard form when you have ax squared plus bx plus c. All you do is you say, what's a, b, and c? You substitute in, and you solve it. Keep in mind you're going to have to add and subtract the square root, so you end up with two solutions. Sometimes those solutions will be exactly the same. Then you really just have one solution. And sometimes you'll have two different solutions, and sometimes you won't be able to find a solution yet because the discriminant here is negative, and therefore you have no real solutions. You will get into that eventually in math called imaginary numbers, but we're not going to get there today. So how do I use the quadratic formula? Let's do an example. We have an a value of 1, a b value of -5, and a c value of -24. We work through this. We do negative b. So x is going to equal negative b is going to be -5 plus or minus the square root of -5 squared minus 4 times 1 times -24. That's all going to be divided by 2 times 1. All right. -5 is +5 plus and minus the square root of -5 squared is 25 minus 4 times 1 is 4 times -24 would be 100 minus 4, 96. So this would be minus -96. So we end up adding these together. All of this is going to be divided by 2. Give myself some more space over here. So this will equal 5 plus or minus the square root of 25 plus 96 is 100, 106, 116, 121. 121, square root of 121, all over 2. Fortunately, 121 is a perfect square. That is 11 times 11. So we take the square root of this. We end up with 5 plus 11 divided by 2, or 5 minus 11 divided by 2. Those become the two solutions here. 5 plus 11 is 16, divided by 2 is 8. Or my other solution, 5 minus 11 is -6, divided by 2 is -3. So 8 or -3 is what x equals 8, or x equals -3. And that's how you would apply the quadratic formula. This is the case where you might need to approximate square roots. You might need to use radicals. This example was a clean one. The next example we do is not clean. All right. This example, we do x equals -b, so -6, plus or minus the square root of -6 squared minus 4 times 3 times 10 Again, 4 times AC, all over 2 times A, or 3. So now I kind of work through this. -6 stays -6, plus or minus the square root, 36 minus 4 times 3 is 12. 12 times 10 is 120. All over 2 times 3 is 6. So now I have this problem. 36 minus 120 equals -84. And x is going to equal this. It equals -6 plus or minus the square root of -84 all over 6. We can't take the square root of a negative number. That is what you call a non-real or an imaginary number that will be able to represent this. But in this case, we end up with a situation we have no real solutions. And that's when you have a graph that won't cross the x-axis. You have a parabola that might look something like that. Since we have a positive a value, if we had a negative a value, it could look something like this or this, right? It just wouldn't cross the x-axis. All right, the discriminant is important because if we just calculate the discriminant, we can answer some questions like, are there any solutions? If this term, b squared minus 4ac, is positive, you have 2 real solutions. If b squared minus 4ac is negative, you have 2 non-real solutions. So we just saw a negative and a positive example where we had 2 real solutions, 2 non-real. We did not show an example where the discriminant is 0. If that is the case, you just end up with 1 solution. And what does that look like? When we talk about the discriminant, if you have 1 solution, it just means it touches the vertex is on the x-axis. So its root is the vertex. 2 real is where it would cross the x-axis twice. It could also look something like this if it has a negative a value. 2 non-real won't cross the x-axis at all. It could also look something like this if it has a negative a value. And that is how can I solve quadratic equations using the quadratic formula.